Welcome to The Explainer. Today, we're not just going to learn to code, we're going to learn how to write a recipe. But this is a very, very specific recipe written for a computer. We're breaking down the 5 fundamental building blocks of the Java programming language by thinking about it in a whole new way. All right, so here's the game plan. First, we'll get to know our kitchen. Then, we'll grab our ingredients, which are called variables. After that, we'll learn the actions, or operators. Then we'll get into the recipe's logic, master some reusable techniques, and finally, get our digital pantry organized. Let's do it. So before we can even think about cooking, we have to understand our workspace, right? Our kitchen. In programming, our chef is the computer. And you've got to remember, this is a chef that follows every single instruction. Every instruction, to the absolute letter. That's really the whole ballgame, isn't it? That's the magic of programming. You see, a human chef might taste something and improvise, but a computer? Nope. It needs every single step spelled out perfectly, with zero ambiguity. And that's exactly what these building blocks let us do. Okay, on to our first and maybe most important building block. You can't bake a cake without ingredients, right? No flour, no sugar, no eggs, no cake. Well, in the world of programming, our ingredients are called variables. And that really is the best way to think about it. A variable is just a container with a name. You might have a bowl that you label sugar, and what's inside? Sugar. In Java, you might have a variable you name score, and you use it to hold a number. Simple as that. And just like in a real kitchen, our ingredients come in different types. These 4 you see here, they're your absolute basics, your bread and butter. An int is for whole numbers, like if you're counting 3 eggs. A double is for decimal points, for more precise measurements, like 1.5 cups of flour. A Boolean is just a simple yes or no. Is the oven on? True or false? And a char, that's just a single letter or symbol. Okay, now this slide is super interesting because it highlights a really key difference. A primitive type, like the ones we just saw, is like having the sugar right there in the bowl. The value is stored directly. A reference type is different. It's more like a sticky note that says, hey, the sugar is in that big canister over there in the pantry. It doesn't hold the sugar itself, it just holds the location of a more complex ingredient, like a whole sentence of text. So we've got our ingredients all measured out in their little containers. What's next? Well, we have to actually do stuff with them. We need to mix them, combine them, maybe compare them. And in Java, all of those actions are done using operators. Exactly. If our variables are the nouns, the ingredients, then the operators are the verbs. They're the symbols, like the plus sign or the equal sign, that tell the computer, hey, do something. And this table just breaks down the main categories beautifully. You've got your arithmetic operators for doing math, like adding 2 numbers. You have relational operators for comparing things, like asking, is this number greater than that one? Logical operators let you combine checks. Is this true and is that true? And finally, you have assignment operators, which you use to put a value into one of your variables, like pouring the mixed batter into a new bowl. A good recipe is way more than just a list of ingredients and actions. It's got an order, it has steps, it has logic. In programming, we call this whole thing control flow. This simple phrase really gets to the heart of it. There's a decision point. Is the mix too dry? If the answer is yes, then we do something, like add water. It's all about making choices and repeating tasks based on certain conditions. So let's look at a super simple decision. Our program can ask a question that has a clear yes or no answer. Like, for instance, is the current hour of the day less than 12? The answer is only ever going to be one of 2 things, true or false. And based on that simple true or false answer, the program literally follows a different set of instructions. If the condition is true, it goes down one path and prints good morning. If it's false, it takes the other path and prints good afternoon. This is what we call an if-else statement, and it's totally fundamental to making decisions in your code. All right, let's keep building on this. Imagine for a second you're writing a cookbook. You wouldn't re-explain how to chop an onion in every single recipe, would you? Of course not. You'd create a standard technique for it. Well, in programming, these reusable techniques are called methods. So a method is basically just a package of instructions that you wrap up and give a name. Maybe you create a method called mix ingredients. Now, instead of writing out all the steps for mixing every single time, you just call the method by its name. It makes your code way cleaner and so much more efficient. And it all boils down to this three-step flow. First, you can give the method some ingredients to work with. We call those parameters. Second, the method follows its own little recipe inside to process those ingredients. And third, it can hand you something back, like a perfectly mixed bowl of dough. That result it gives back, we call that the return value. All right, things are starting to get a little complicated. We've got all these ingredients and we can't just leave them scattered all over the counter, right? We need to get organized. And that brings us to our final building block, our digital pantry, which we call data structures or collections. So the simplest organizer is something called an array. And honestly, the best way to think of it is an egg carton. It has a fixed number of slots, say 12, and you can only put one type of thing in it, eggs. You can't just decide to put a carton of milk in one of the slots. An array is the same way. Fixed size, and all the items have to be the same type. But what if you don't know exactly how many ingredients you're going to end up with? For that, you need something more flexible, like a shopping bag. And that's an array list. You can just keep adding items to it and it grows. Take some items out and it shrinks. It's dynamic, which is incredibly useful for all sorts of real-world situations. So there you have it. We have walked through the entire kitchen, from the tiniest ingredient all the way to the pantry shelves. Let's just do a quick recap of how all these pieces fit together to create our very own digital recipe.
These are the absolute keys to the kingdom. You start with variables, that's your data. You use operators to do things with that data. You guide the recipe's logic using control flow. You package up common steps into reusable methods, and you keep it all neat and tidy with collections. Seriously, every piece of complex software you've ever used is built from these same simple ideas.
And that's our explainer. The big takeaway here is that programming isn't some kind of dark magic. It's just logic. It's like building with Legos or, following a recipe. Once you master these core concepts, you really have the tools to start building pretty much anything you can imagine. The only question left is, what are you going to create?